Hi, this is Mrs. Bustamante again, and this is going to be our last video in our descriptive statistics series. So here I have some made-up data set. Again, we're just going to use it to talk about what we see. You'll notice my 95% confidence intervals are already drawn there. So here's some questions that you're going to have to walk yourself through in order to decide basically, does your data show a statistically significant difference or not, right? So the first question you're going to ask is, do these error bars overlap each other? Well, if I draw this over here and this over here, you'll notice that they cover the same space on the graph. So this part could fall into this range. Even if some of this doesn't cover this entire area, we say that yes, these error bars overlap. They cover some of the same space, if you will, or range on my y-axis. So if I picked, say, a data point right here, right? Could that data point fall into group A according to my error bars? Sure, it could fall into that 95% confidence interval. What about group B? Could it fall into that confidence interval? Yes, it could there too. Or I could pick a point, say, here. Could it fall into group A or group B? Yes, it could. Okay, so we would say yes for this data set here. So what do I use that for? What does that mean to me? Well, that means that my data is actually inconclusive because my 95% confidence intervals or my error bars overlap. It means that my independent variable here, I can't say for certainty, or at least statistical certainty, that it caused a difference in the two data sets. So what if your confidence intervals do not overlap? What does that mean? Well, then we say there is a statistically significant difference in your groups, and something that you changed about your independent variable you were testing, you would say had a statistically significant difference. Maybe it could be attributed to whatever it would changed, right? So this isn't really probably necessarily what you're looking for, right? You're probably looking to see a change in your independent variable. And it's possible, right, that you could look at all this data and never see that change, and that would in and of itself be a conclusion, right? But how would we know for sure, right? How could we get better data or not have our data overlap? Okay, well, we say that more data equals more better, right? And I say that kind of jokingly, but we know in science, if you have a sample size of 50, like, that's pretty good. But what if you have a sample size of 500 or 5,000 or 5 million, right? If you were doing some sort of clinical trial, you wouldn't just want 100 patients, you want 1,000 patients or even more, because you know that that gives you more data, and so you can draw more meaning from that. So if you wanted to get more data, right, that would help your standard error of the mean. So let's look at this standard error of the mean equation and see if that doesn't make sense. Well, n is sample size, so if n is in the denominator, the bigger it gets, the smaller your 95% confidence interval gets. So this lowers your standard error of the mean. So 2 times your standard error of the mean means that you're getting a smaller 95% confidence interval. And this is why we statistically say that you want a bigger sample size, not just because your teacher has always told you that in science, right? So if you're analyzing your data and you see an overlap in your 95% confidence intervals, so we would say that there is no statistical significant difference between them. What would you do? Well, you'd say, let's get a larger sample size. And maybe by getting a larger sample size, you might get small enough error bars that you could then deem your results conclusive. And you could say that they caused some sort of a change to occur in the results. And that's the whole point point of understanding standard deviation, standard error of the mean, and your 95% confidence intervals so you can draw conclusions about the significance of your data.